Good morning, students. As we have finished our chapter in a last lecture, today we'll see about the numericals based on chapter lens from a exercise. So let's start with the first question. Let's read. Doctor has prescribed a lens having power positive 1.5 diopter. What will be the focal length of the lens? What is the type of the lens? And what must be defect of vision? So what the question says, we have given that power of a lens as a 1.5 diopter. You can see a plus sign. So what that plus sign indicates? It indicates the power of the lens is a positive. So if you remember in the last lectures, we have discussed about the power of lenses, and in that we have mentioned the 2 points: power of the convex lens and power of the concave lens. So that part you are going to use here. Even before solving also your answer has to be ready. Which type of lens is this? So what do you think, which type of lens it will be? So its power is a positive, means it is going to be your convex lens, because the focal length of the convex lens is going to be positive, and therefore the power is positive, and as power is positive means it's a convex lens. Let's see how we are going to do. So what is given to us in question? We are given that power of lens. We know that P used for the power of lens is equals to plus 1.5 diopter. To find focal length f, type of lens, what type of lens is this, whether it's a concave or convex, and what is the defect of vision. We have studied the three defects of vision, that is a nearsightedness, farsightedness, and a presbyopia. So out of that, which defect of vision this particular patient will be having, that we have to find. So let's start solution. We know the formula, power of lens is equals to P equals to 1 upon F. We know the power is nothing but reciprocal of the focal length. Therefore, P is equals to 1 upon F. Now in this question we are given the power, and therefore the formula will be rearranged as F is equals to 1 upon P. Correct? This F is divided here, comes to the left side, becomes multiplied, and this P is multiplied. When it comes to the right side, it becomes divided. So F is equals to 1 upon P. Therefore F equals to 1 upon, what is P now? It's a 1.5. Therefore 1 upon 1.5. To remove this decimal, we'll multiply denominator by 10. So as denominator is multiplied by 10, numerator also multiplied by 10. Therefore F is equals to 10 upon 15. If we carry out this division, see, suppose if you are going to divide here, what you can get 15. If you are going to do, so 15 ones are 15. Here we can't divide first, it's 10, therefore 0. Correct? Then decimal, it becomes 100. So 15 6 are 90, and 15 sevens are 105. Therefore we'll take 15 6. Correct? As 15 6 are 90, so 10 minus 100 minus 90, again it is 10. So again it will become 15 6 are 90. Again same, means it will be continuing the 0.6666. So by approximation you can say it is a 0.667, and further approximation we will see F is equals to 0.67 meter. As you know, when the number decimal is 5 or more than 5, we are removing that and increasing the earlier one by 1. So suppose this 7, then this 7 is removed and this 6 becomes 7. Again, due to this 7, this 6 becomes 7, and this 7 is removed, so it is 0.67 meter. So what you can say, the focal length of the lens is a positive 0.67 meter. Now why it is positive? Because our power is positive, means obviously the focal length is going to be positive. So your first part, that is a find a focal length. So focal length of lens is a positive 0.67 meter. Now as the focal length is positive, in which lens you are having the focal length is positive? So as you know, in convex lens, when you draw the ray diagram, in that you have seen, when in a convex lens the focus is on the right side, and therefore right side of the lens is a positive, means now the focal length for the convex is a positive. Correct. So now your focal length is positive, means with what type of a lens it is? So it is your positively sorry, it is your convex lens. Okay. So the as focal length is positive, the lens is a convex lens. Okay. And as in the last lecture we have discussed in a defect of vision, in that we have studied the farsightedness. Correct. In the farsightedness you have studied the lens used for the farsightedness cure is nothing but your convex lens. Correct. In farsightedness you can see the nearer farther object you can see properly, but nearer object you cannot see properly, and therefore to cure that defect farsightedness you are going to make use of a convex lens. Correct. Any doubt? Let's move to the next question. Question number second. 5 centimeter high object is placed at a distance of 25 centimeter from a converging lens of focal length of 10 centimeter. Determine the position, size and type of the image. I can understand the question first. What you are given, 5 centimeter high object is placed at a distance. So what is the height of the object is given? 5 centimeter. It is placed at a distance of 25 centimeter from the converging lens. Means it is kept at distance of 25 centimeter. Means distance of the object from the lens is given as 25 centimeter. Now your point, converging lens. Converging lens means which lens it is? So again we have studied converging means the when the rays are going to converge, the lens which converge the light rays, that lens is called as a convex lens. So means in this question we are using the convex lens only. So remember, convex lens and the converging lens is the same. The focal length of that converging lens is given as 10 centimeter. We have to find the position where the image is located. Means in short we have to find the distance of the object. Size, whether the object is big or whether the object is small, means we have to find the height of the object. And what is the type or the nature of the image, whether it's a real or the virtual, that you have to see. Okay, let's see. Given converging lens, the lens is which lens? Converging. So that is also we have to write which is a converging lens. The focal length of the lens is f is equals to 10 centimeter. As I told you, distance of object u, we write the distance of object as a u. Distance of the object from the lens, it is given as a 25 centimeter, but I am writing here minus. In the question it is not mentioned anything distance of 25 centimeter, but I am taking here minus. Why? Because as we have studied the sign convention, object is always placed on the left side of the lens, and left side you are going to measure the distance as a negative as per sign convention, and therefore you have to take here minus 25 centimeters. So you have to keep this in mind. In a question they will not say anything, sign will not be given, but you have to see what is given, whether it is the distance of object or the distance of the image. Again, if it is given distance of the image, where it is formed, that also you have to see. Okay, that will see further. So distance of object u equals to minus 25 centimeter. I hope why you understood why I took here minus, because the object is always kept on the left side of the lens. Next we are having height of the object, h1 is equals to 5 centimeter. See again sign convention. I'm not taking here plus minus. Why? Because h1 means height of the object, and object is always in a erect position. Means it is always on the upward side, perpendicular to the principal axis and above the axis, and therefore it is always positive. So h1 is equals to 5 centimeter. To find distance of image, that is v, we know that distance of image is denoted by v, height of the image, that is h2, and type of a image. The image form is a real or the inverted, magnified or diminished, that we have to see. Solution. So from the lens formula, for this sum you are going to make use of this lens formula, that 1 upon f is equals to 1 upon v minus 1 upon u. So now here you have to find the image distance, means we want to find v. F is already given. F is already given to us. U is also given to us. Means what you have to find? V we have to find. Correct? Distance of image. And for this we are going to make use of this lens formula. So 1 upon F is equals to 1 upon V minus 1 upon U. So now to get the V, we have to rearrange the formula, and after rearranging the formula you can see you are getting 1 upon V is equals to 1 upon F plus 1 upon U. This 1 upon U is shifted on the left side. Correct, it is written here on the right side, but actually 1 upon U is shifted here, so this minus becomes plus. Therefore 1 upon F plus 1 upon U, which is equals to 1 upon F value is what? 10 centimeter. So 1 upon 10 plus 1 upon U is a minus 25, therefore minus 25. So this plus minus is becomes minus, therefore equals to 1 upon 10 minus 1 upon 25. Now to take a LCM, we know that 10 5s are 50 and 25 2s are 50. Means this part here I have multiplied by 5. Correct? And for this one I have multiplied by 2. So therefore 5 ones are 5, 5 tens are 50, minus sign as it is, 2 ones are 2 and 25 twos are 50. So denominator is written only 1. So 5 minus 2 upon 50, which is equals to 5 minus 2 is equals to 3 and upon 50. Okay, so what is your answer? 1 upon V is equals to 3 upon 50. Now you want to find the V. Therefore, you are going to do the invertendo in maths. You have studied what is invertendo. Invertendo means exchange of numerator and the denominator. So by invertendo, V is equals to 50 upon 3. It will be interchanging. Now if you divide 3 ones are 3. Correct? I think no need of showing the division. 3 ones are 3. 5 minus 3, 2. So becomes 20. So again 3 6 are 18. 20 minus 18 remains 2. Therefore decimal, and again 20. So again 3 6 are 18. 3 6 are 18. 3 6 are 18 will be continued. So that will be approximated as a 6 7. So V is equals to 16.67 centimeter, which is further approximated to 1 decimal as a 16.7 centimeter. And therefore you can say the distance of image V is equals to 16.7 centimeter. Means when you are going to make use of converging lens of focal length 10 centimeter, if you are going to place the object at 25 centimeter, you will get a image at a 16.7 centimeter. Okay, again you can see here you are getting plus, no minus. Means from that you will come to know that the image is formed on the right side, it is not on the left side. Correct? Because distance of the image is a positive. Next we have to find, that is the height of the image, and for that you are going to make use of a formula, magnification. So now by using a magnification formula, you know that h2 upon h1 is equals to v upon u. Correct? So now again here we have to find the h2. So again you are going to rearrange the formula. So h2 will be as it is, this h1 is divided here, when goes here multiplied. So v upon u into h1, which is equals to v. You can take 16 upon 16.7 directly, but that may create a confusion. and therefore instead of this decimal form we are going to take in a fraction form only. So therefore v is a 50 upon 3 upon u is a minus 25 into h1 is given as a 5 centimeter. Correct? H1 is given as a 5 centimeter here. So into 5. So now 50 upon 3 upon minus 25, therefore that 3 will come down. So this 5 is multiplied. So 15 to 5 upon 25 upon 3. This minus I put in the middle because we know that minus cannot be put in the denominator. So that is taken in the middle. So now doing calculation, 25 ones are 25. 25 ones are 25. 25 twos are 50. 5 twos are 10 upon 3 minus 10 upon 3. Again 3 ones are 3. 3 threes are 9. Correct? And that will be continued. 3 point again remains 1. Again decimal and 0 10. So again 3 threes are 9. Again 3 threes are 9. So it will be continued as 3.33 dot dot dot, which approximated as 3.3. It is minus. Correct? So now you can see your height of the image is 3.3, but height is given in minus. So what it will be indicate, what that minus sign is indicating? Any idea? Correct. So that minus is nothing but your image is inverted. Minus is downward. It is perpendicular to principal axis, but it is below the principal axis. Means it is a inverted. Means your image is going to be inverted. So height of image is h2 equals to minus 3.3 centimeter, and minus sign indicates inverted image. What that minus sign is for? That minus sign is going to indicate your image is inverted. Clear? So now from next part you have to find that is a type of image. So what will be the type of image? Distance of the image is 16.7 positive, means it is on the right side. Correct? And minus sign is in the height is given, means it is shows that the image is inverted. So object sorry, image is on the right side, it is on a inverted, means what will be the type of image? So it is going to be a real image. Okay, so the image is real, inverted and smaller than the object, as it is on the right side. Again remember, when the image is formed on the right side, it is a real image. If it is formed on the left side where the object is, means you have to remember it is a virtual image. So as you have drawn the ray diagram, in that you have seen when you use a convex lens you are having the real image. In case of only one, I think you are going to have a virtual. When you are going to place the object between the optical center and the focus, then you will have a virtual image in case of a convex lens. Otherwise everywhere you are going to have a real image. And in case of a concave lens, you are all having the virtual image. Okay, so remember, whenever the image is formed on the right side and inverted, means the nature or the type of the image has to be real. Okay, so that part you have to remember. The image is real, inverted. So why it is real? Because you can see it is formed in the right side, as this distance shows positive, so it is formed on the right side, mean that because of that it is a real. Now why it is inverted? Because the height is a minus. Height is minus, therefore the image is inverted. And why it is smaller? Because you can see the height of the object is 5 and height of the image is 3.3. So obviously it is a smaller. Clear? So let's move to the third question. Three lenses having power 2, 2.5 and 1.7 diopter are kept touching in a row. What is the total power of the lens combination? So again you have studied about the power of a lens of combination. When the lens are in a combination of the lens you have studied. I think I have put up the video about that combination of lens. Correct? So you have seen that video. If not, you just go and see that video. So now when you are going to make use of three lenses of a power 2, 2.5 and 1.7 diopter touching in a row, they are kept touching in a row, means they are arranged in the row, they are not arranged in the column, correct? So as you have studied about the resistance, 9th standard you have studied na, series and the parallel. So here they are not kept up parallel, they are kept in the row, means they are kept in a series, correct? So same concept you are going to make use here also. So what is given to us? Power of the three lenses as P1 2 diopter, P2 2.5 diopter, and P3 1.7 diopter. So these are P1, P2, P3 is nothing but power of the first lens, power of second lens, and power of the third lens. To find, what you have to find? So total power of the lens combination. So when these lenses are going to be combined together, so what is the total power? So here we are taking P1, P2, P3 for the individual, and the total power will consider as a P. So how to find? So you have studied the formula, as I told you, the series case same pattern. So here power is given, so you are going to be said as the equivalent power is nothing but the power of a individual lenses, and therefore we say total power of the lens combination P is equals to P1 plus P2 plus P3. You have studied that. You can go and read in the textbook that the equivalent power of the lenses when they are combined is nothing but the sum of the power of the individual lenses, and therefore P is equals to P1 plus P2 plus P3, which is equals to 2 plus 2.5 plus 1.7. It's nothing but 6.2 diopter. So when three lenses are arranged in the row, the combined power of all the three is nothing but sum of their individual power, and it is nothing but 6.2. You can say 2.0, 2.5, 1.7. So 7 plus 5 is nothing but 12. So 2 carry 1, 2, 2, 4, 1, 5, and 1, 6. So 6.2 diopter. It's very easy. Some can be asked for like this. Questions can be asked for 2 marks, or it can be asked in 1 mark MCQ type questions also. Okay. So just revise it properly. Let's move to the last question. Question number 4. An object kept 60 centimeter from a lens gives a virtual image 20 centimeter in front of the lens. What is the focal length of the lens? Is it a converging lens or a diverging lens? So see, you have to read the question properly and your answer has to be ready here only. What is given to you? An object kept 60 centimeter from a lens. Means what it is? It is given the distance of the object, that is u equals to 60 centimeter, correct? It gives a virtual image 20 centimeter. Now here important, who is going to tell me? Virtual image. Virtual image means what? It will be forming on the left side only, not on the right side. Okay. Image 20 centimeter in front of the lens. So what is this 20 centimeter? It is my distance of the image. But what it will be? Now it is a positive or negative as per sign convention? Huh? Correct. So it should be a negative because it is on the left side only, the virtual image. The image is a virtual, means it is going to be negative. We'll see further. So what is the focal length of the lens? So what will be the focal length now? The image is formed on the left side, means the focus is on the left side. So what will be the focal length? It has to be again negative. Okay, let's see the further what is given. So distance of object u is equals to minus 60. As we said, it is on the, as per sign convention, the object is always on the left side, therefore it is minus 60. See, again, it is not given in question, but you have to remember sign convention properly, and therefore it is a minus 60. Again, distance of image v is equals to minus 20. Again, it is not given anything negative, positive, but we are taking it minus 20 because it is mentioned here virtual image, correct? See here, it is mentioned as a virtual image. Virtual image means the image is on the left side only, and therefore you have to take it as a minus 20. Okay. What you have to find? So to find focal length of the lens, that f is equals to question mark. Okay, what is the focal length of the given lens? And second, we have to find what type of the lens it is. Is it a converging lens or a diverging lens? That also we have to find out. Solution. So again, here also you are going to make use of your lens formula, because you can see you have given a u, you have given a v, and we want to find the f, and therefore again we are going to make use of a lens formula only. So that is 1 upon f is equals to 1 upon v minus 1 upon u, which further gives 1 upon f is equals to 1 upon v is minus 20 minus u is a minus 6, so 1 upon minus 60. So therefore you are getting 1 upon f is equals to minus minus taken outside, you can see the minus common, so 1 upon 20 minus 1 upon 60, correct? This both minus has taken outside. Now here also minus, here also minus, here also minus. So therefore this middle sign is not changing. These both minus are taken outside. So 1 upon f is equals to, again here also taken the LCM. See here 20 and 60. We know that 23 is a 60. Therefore this one is multiplied by 3. Correct? For this one there is no need, because already it is a 60. So only the first fraction is multiplied by 3. So 3 ones are 3 minus 1 as it is, and here denominator as a 60. Correct? Okay, so 3 ones are 3 minus 1 upon 60. This minus will be as it is. So is equals to 3 minus 1 is nothing but 2 upon 60. Now if I am going to divide it, so 2 ones are 2, 2 threes are 6, so 30. So minus 1 upon 30. So now here also you want 1 upon f, 1 upon 30. You want to find the value of f. So again, maths formula, invertendo. So f is equals to minus 30. Correct? Reciprocal you are going to take. So f is equals to minus 30. So what your question is, you have to find the focal length. So what is the focal length? It's nothing but your 30 centimeter, but it is a minus, means what that minus indicate, the focus is on the left side, means the your focal length is going to be negative. Okay, now as again I told you, as we have studied in the chapter, the which lens is having the focal length negative. Ha, correct. So your concave lens is going to have a negative focal length. Correct. Means what type of the lens is this? So it is a concave lens. But they are asking the question concave, convex. They are asking is what, converging or diverging. So what type of the concave lens is? So concave lens is your diverging, because it's going to diverge the ray. Correct. And therefore your further answer, it's nothing but the focal length of the lens f is equals to minus 30 centimeter. As the f is negative, it is a diverging lens. Correct? I hope you have understood. This negative sign indicates that focal length is a negative. Focal length is negative means it is on the left side of the lens, and as it is the left side means which lens is having the focal length negative, that is your concave lens, and concave lens is also called as a diverging lens, and therefore the answer is a diverging lens. I hope you have understood all four questions. Same like these questions only can be asked in an exam. Maybe numbers will be changed. But here you have to remember only these three formulas, that is the lens formula, magnification formula, and the power formula. Correct? And you have to remember the relation between the power of the lens and the focal length. That is the inverse of each other. And another that main points, the focal length of a convex lens is a positive and focal length of a concave lens is a negative. These two are the very important points which you have to remember, which you can give the answers directly. And another important thing is that sign convention, because in a question they are not mentioning anything positive negative. By reading the questions you have to understand where the object is and how it is, and based on that you have to apply a sign convention. From that you will get negative positive. Okay, so just go through the video properly, and if you have any doubt you can contact me anytime. Thank you. God bless you.